Kia ora koutou. So just welcoming Scott Wilson, who's come from Lincoln Agritech today. Really looking forward to talk. Scott's an expert in braided rivers and how they interact the surface water and the groundwater. I've seen Scott speak before, so I know that we'll get a really good insight into how these rivers operate. And my hope is that we can take this away with us and understand some more around future and how we need to think about these rivers and how we might think about policy and what the science team are doing and so on. So I'll let Scott, what we'll do, we'll have Scott go through the presentation, hold questions. So if you can make notes, councillors, of questions you want to ask, and we'll do those at the end so Scott can just keep on a flow. We are live streaming. So anyway, I'll, with no further ado, Scott, please introduce a bit more about your background and jump in and thank you so much for coming. Kia ora.
Thank you. Kia ora. So I'm Scott Wilson and I'm at Lincoln Agritech at Lincoln University, and my background is as a hydrologist slash hydrogeologist, and I'm particularly interested in how rivers and groundwater interact. That's my kind of niche. So I've just finished leading a 5-year MB-funded research program called Subsurface Processes in Braided Rivers, and that was around trying to understand how braided rivers work beneath what you see at the surface. So trying to understand the subsurface hydrology and how those river systems interact with groundwater. And also to try and understand how river management might be affecting that interaction between the river system and the groundwater system. Kind of start off with a little bit of history, really. So when the early settlers arrived here, they were kind of faced with a couple of really big problems. One was that there was a lot of flooding in these types of rivers. They weren't used to that. A lot more flooding than what they were used to back in England. And there's also a lot of sedimentation coming mainly from land clearance and fires and whatnot. So there was a lot of erosion and a lot of flooding. And the problem with the erosion and the sedimentation was that the river bed loads are really high. And when the river bed loads are high, the sediment builds up and it makes the river unstable. So it can move sideways, can move a little bit randomly in any direction and flood parts of the plains that wouldn't previously have been flooded. So they needed to find a way to kind of control the position of the river. And that meant controlling the amount of sediment that the river was carrying. So through a long process of grappling with these rivers, a pivotal act was passed by government in 1941, the Soil Conservation and Rivers Control Act. And that was quite pivotal in our hydrological history, because what that act did was it established catchment boards. And those catchment boards were tasked with reducing flooding and also reducing river bed loads. So they had to look at erosion, and which is where the soil conservation part comes in. And one key thing about this is that it had central government funding. And so what that enabled was the rollout of large-scale engineering schemes, which people have called command and control river engineering schemes. And those were implemented from the 1960s all the way through to the 1980s. And what those schemes were based on a design river. And the idea was really to try and realign and narrow the rivers so that you could carry more sediment out to sea and move water through the river system, through the catchment more efficiently. So what they did was they created what's called a conveyance channel to carry water most of the time. And then on the margins of that conveyance channel there were some berms. So you had these edges, and they were usually planted. And then you had stop banks set further back. So when the river flow got really high, the water could spill out and it would reach those stop banks and not go any further. But the idea is that most of the river flow is carried within that little conveyance channel. And the benefits of this was that it really increased the channel flow velocity. So you could much more efficiently get rid of water when you had a big heavy rainfall event. prior to doing this, braided rivers, they have a tendency, when the flow goes up, they don't tend to the water table doesn't tend to rise on the river, they tend to spill outwards. And so what this did was it changed the way the river operated. So rather than spilling out laterally, spilling out sideways when the flow came up, the flow would actually rise. And so part of this was trying to get rid of sediment and dropping the bed a little bit into the landscape, so that you created a little bit of a sort of like trough to sit the river in. And then the water table within the river system would go up and down within that trough and only spill out onto those berms when you had a really high flow. The other aspect of this is that by increasing the velocity of the river, you also increase potentially the sediment transport efficiency. So you can get rid of sediment more rapidly. And this was based on a theory which was put forward by a fellow called Lacey back in the 1930s. This is an example of what happened. This is a really good example of a river design. It's not a Canterbury River, but I think it's a particularly good example to illustrate some of the concepts. So this is a river from the 1950s, and you can see that it's quite wide. It's got a very large active braid plain, a lot of bare gravel there, and the river's got quite a lot of braids which are moving all the way across that active braid plain. And so what the river engineers did was they got out their flexi rulers and they drew a conveyance channel over the top of that, which is shown there in the blue lines. And then they designed some stop banks, and shown in red there, to stop the high flows from spilling out onto the plains. And when they actually implemented this, what they did was they got out there with some diggers and bulldozers, and they actually dug that channel out to some degree. So they extracted quite a lot of gravel to drop the bed so that the river would sit within those two blue lines. And then they planted out the margins and willows. And the result is what you see in that river today. So the same lines are drawn there on a photograph, which is quite recent. And you can see the old river system margins in those black dashed lines. So in this case, the river has been roughly halved in its width. What's not shown on here is that there's been quite a lot of gravel extraction in this river. And even though it's a depositional part of the river, so there's a natural build-up of sediment in this part of the riverbed has been dropping over time because there's been so much gravel extraction. And the mean bed level over that whole section of river there has dropped by 1.5 metres since the 1980s, since the scheme was implemented. So it's quite extreme. But I have to reiterate, this is not a Canterbury River. It is a Hawke's Bay River. That's the Ngunnawara. Yeah. So this one actually, it failed. There's an obvious pinch point in that river. There's a bridge on the right-hand side, and you can see the township of Mahu or Fernhill. Yeah. So that got flooded in Cyclone Gabriel, mainly because it got that narrow point there that caused a bit of a pinch. So the stop banks failed. So this is the current situation. We've inherited these rivers, these designed rivers, and what's happened is the natural sediment supply of many rivers has decreased. Not all rivers, like there's a lot of rivers in parts of the country where the sediment supply is continuing to be really high, but in a lot of, particularly the east coast of the South Island, the sediment supply is going down because you're getting a lot more vegetation in the catchment. There's also an increased demand in gravel for building, for construction, for roading, in the vicinity of towns and cities. So that's gone up, the demand's gone up, supply's gone down. And the result of this is that we're tending to see a continuing decline in the bed levels in these rivers around populated areas. And it happens around populated areas because gravel is very expensive to move. So it tends to get extracted close to where it's needed, which is, around cities. On top of this, we're starting to get a lot more weed growth. So if the rivers look like they did in the 1950s, we had all that bare gravel, the grade plane would actually be covered in a lot of weeds now. You certainly need a certain amount of energy in the river system to clear the weed growth. This is a photograph of the Waimakariri looking towards the coast, and if you look closely, you can kind of see that the bed has dropped a little bit within that active fairway, and on the margins there's an encroachment of weeds that's starting to occur in places. What that tends to do is it tends to lock up the sediments, and so when you get a high flow in the river can't move those gravels very easily, and so the river tends to erode downwards. So that's another problem that we have, that we're faced with now. And we're also facing future climate stress. But fortunately, our hydrological knowledge has increased. It's increased a lot since the 1960s. And the models that we have available now to try and predict behaviour of systems has increased massively. One of the main changes is that values are no longer the same as they were in the 1960s. As part of our research program, we canvassed a lot of the values that people associated with rivers in the regions that we studied. One of the things that comes to the fore is the massive increase in awareness that of the value of rivers for tangata whenua, but also lots of other values. For example, the value of river water for irrigation and groundwater for irrigation is much more now than it was back in the 1960s. Throughout the country, the demand for gravel started to increase in the mid to late 90s. And then there's a lot of other amenity values that we can see there. So it's not just flooding that we need to mitigate. That needs to be a primary value. But there's a lot of other values that need to be accounted for. And one thing I have to commend the ECAN river engineers for is their move towards trying to include a larger value base in their river management. But despite that, they still inherited a system of flood management that was established in the 1960s. And that makes things challenging. Let's have a quick look at some of the impacts that those river schemes have had. Firstly, there's been a massive ecological impact. Bed narrowing and lowering of the bed, those two things have had a huge impact on ecology. So you end up with what's kind of like a binary system. You're either in the river system or you're outside of it. Back in the 1950s, before the schemes were implemented, the margins of the river were much more difficult to determine. You had this kind of continuum of landscape, a continuum of hydrology, and that's changed. So you're either in the river system where there's a bit of water, or you're outside of it now. So it's had a huge ecological impact. It's had a big impact on groundwater recharge, and the impact that a river engineering scheme has on groundwater recharge depends on the river system, which I'll talk about soon. But it's also impacting the flow regime. So we're getting faster flow recession, so you get a high flow, and because the efficiency of the river system has been increased, the river flow drops more quickly, which is a good thing, but that can impact the water balance as a whole. And we're also getting a change in the bed profile of the river, which is also changing the way rivers flow and interact with groundwater systems. The bottom line message here is that the way rivers are being managed does influence the mass balance, particularly in Canterbury. You've got such high flows in Canterbury rivers, and they are the main source of water for the Canterbury Plains. Small changes can make a big difference to the amount of water that's available in the river and in the groundwater system. So this is the way we have now considered rivers based on the research that we've done. Really focus on the top right diagram. Unfortunately, the writing's a little bit small, but one thing you'll notice there is that there's sort of like a blue area there that's like a trough. So if you if you cut through the river and looked upstream or downstream, the river system would look something like that. You've got a whole lot of channels on the surface, and beneath that there's a bit of a trough, and that trough is composed of gravels which are moved by the river when there's a flood flow. So you get a flood flow and the sediment gets moved by the flood flow because there's so much energy in the system. And what that does is it winnows those gravels, it cleans them. And so you end up with a deposit which is quite coarse and really highly permeable. And that forms a reservoir which the river interacts with. So it's best to consider a braided river as a system which consists of the channels, that gravel that gets moved during flood flows, and the water held within those gravels. And we can actually see that that river system is distinct from the surrounding sediment and the surrounding aquifer. So if we think of that as a river system, that sort of blue trough there, that can either be sitting within the water table, and if it does that, that's what we would call a connected system. So the regional water table and the river system are connected. They're kind of exchanging with each other. In other words, the river system is sitting within the water table. And when that happens, water interacts with the groundwater system from the river system. It moves sideways, laterally. It doesn't tend to go downwards. The other situation that we find is where the river system sits above the water table and it leaks vertically downwards to it. This is a little bit like if you fill your pot plant up with water and you lift the river rate. So in the top one, where the river system sits within the water table, the exchange between the two is entirely driven by the level. So if you drop the riverbed, you decrease the groundwater level. You also decrease the amount of recharge that goes into the aquifer. Whereas if you raise the river level, you increase the flood risk a little bit, potentially, but you also increase the groundwater level and increase the amount of recharge. In the perch situation, which is what most of the Canterbury Plains is, particularly the upper parts of the Canterbury Plains, if you narrow the river system, you decrease the amount of recharge because you make the area that the river covers smaller. Conversely, if you make the river system wider, you increase its area, and so you can increase the amount of leakage that comes out of the river to the groundwater system. So that connected scenario is found around the coast. Essentially, once you get around State Highway 1 and you see springs emerging, that's where you get that connected scenario. The upper parts of the Canterbury Plains are more that perch scenario. So we're seeing this influence of river engineering on the hydrological system. And it's so if the system's perched, the narrowing of the river system has affected recharge. If the river system is connected with the groundwater, then the riverbed elevation or level is affecting groundwater recharge. And the other thing which needs to be thrown in here is that the riverbed profile, or how undulating the river is, also influences that exchange. And that influences the exchange for all systems. So what I mean by the bed profile is if you look at the bed, it's like how bumpy the surface is. So in a really braided river, the bumps are quite small. But you can also get rivers where the channels are deep and there's less braids. So the bed profile there is quite steep. And for hydrological functioning, it's actually better for a river to be more braided. This is just a snapshot from Canterbury Maps looking at the Waimakariri. So that's what it looks like today, and you can see those sort of forested margins. If you go back to the 1940s, the river covered a much larger area. So it just gives you an idea of what's happened to the Waimakariri. Just looking at the vertical changes. So those black lines in that map, those are cross-section surveys. And what I've done is I've just plotted up the change in those cross-section surveys over time. And I've used 1997 as a baseline. So there was a survey done in 1997, and every 4 years the cross-sections are surveyed again. And I've subtracted each survey from that 1997, and you end up with that graph at the bottom. So on the x-axis at the bottom, you've got distance from the coast, State Highway 1 on the right, and Courtenay on the left. And you've got the bed level change on the left-hand axis there. So if the line is above 0, that means the bed's gone up since 1997. If it's below, it means it's gone down. And you can see that mostly the bed has dropped since 1997, which is when, after that time, the gravel extraction really started to increase on the Waimakariri. So that's resulted in that bed level decline. And it's been quite severe in the sort of, I think it's Coots Island area, at around about 10 kilometres from the coast. Interesting, there's been a really nice recovery in recent times, so it must have been recognised that there was too much gravel being extracted. And you can see that red line, which is the most recent survey, the bed has gone up a little bit in the lower parts of the river around State Highway 1. But in general, we're seeing a long-term decline in the riverbed. So if we move to groundwater levels and look at the impact that that's having on the groundwater system, we can see that there's also a decline. Those blue dots in the map, those are some monitoring wells that ECAN has, and they correspond to the water levels on that graph that you see at the bottom. And the numbers on the x-axis in this case are time, so we're starting in 1994 and we're moving forwards to 2025. And you can see that in each case the groundwater level is declining. This is just looking at the information another way, plotting two cross-sections, one up at Thompson's Road at the top of the system, so that's that blue dot there, and one at Crossbank, which is that kind of teal red kind of area further downstream. And you can see that the bed's going down and the groundwater levels are going down too. So the bed in this case is shown on the dots and the dashed lines, and the groundwater levels are shown in the solid lines, and those seeing a decline in both cases. We did some economics as a part of our study, and some of the conclusions I'll quickly go through from the Ngātaroa and Wairau rivers. One is that river widening scenarios tended to be economically beneficial overall. Bed level raising scenarios, likewise, tended to be positive overall. They did come at a cost of reduced gravel extraction and some stop bank work, but the environmental benefits of raising the bed were huge. And bed lowering scenarios that we looked at were all negative. The only advantage of bed lowering, continued bed lowering, was the impact that it has on gravel extraction. So how do we address this? We can engineer more water, and that does have its place, but it's expensive to create, and it does require maintenance. The thing about a river system is that it's constantly cleaning itself. Every time you get a flood flow, the gravels get turned over and you get winnowing of the fines. With reservoirs, particularly if you're looking at a MAR scheme, you end up with siltation problems. And the bottom line, I think, is that it doesn't really address ecological issues or necessarily tangata whenua issues and a lot of other values. It doesn't really address the underlying problem, and that is that there's unintended consequences of altering the water balance through flood management. So one thing I'd like to suggest is that there's an alternative way to approach water strategy in Canterbury, and that is really to reconsider the value of rivers. Firstly, that involves understanding how the river system functions, and secondly, understanding how that functioning has been compromised through the interventions that we're doing, and thirdly, understanding the economics around river restoration, and lastly, to do this, requires a certain amount of work across disciplines, which is something that none of us do particularly well. But if we do that, then we can move towards improving water security without compromising flood protection. That's it for me. I hope I haven't talked too long. But, yeah.
That was lovely. Thank you very much, Scott. Has anyone got a question they'd like to ask? So we've got Genevieve.
Thank you so much. I've learned a lot already. With regards to the narrowing of rivers and less natural recharge you just talk about, is it more likely too that, especially in that coastal environment, you'd get more salination of aquifers in that situation where there's not enough recharge?
Yeah, Sorry, my microphone was off. It's not something I've thought about, actually, to tell you the truth. It's possible. Yeah, certainly one of the things that is potentially happening is that you're getting a lot less dilution of nitrate, if you reduce recharge from rivers. That's the main dilution that's available for diluting nitrate. But I'm not sure about the coastal region, sorry.
With regards to natural recharge versus managed recharge, do you see a difference in the two, if you've ever looked at that?
Sorry, I'm off again. I haven't looked at it, but every time. Yeah, I have looked at it in the Wairau because it's a current problem that we're looking at, and it's an issue of scale. You cannot possibly replace the scale of what's happening in a river system with an artificial recharge approach. And the reason for that is that the scale of the hydrology and the scale of the losses in a river system are just so large. You cannot possibly create that through an offline engineering approach. When you think about it, you take a river, it's got, potentially hundreds of cumecs flowing through it, and the losses can be, sort of half a cumec, for every kilometre or a few kilometres. So the amount of losses through these river systems are huge. You can't possibly replicate that for an engineering approach. Yeah.
Thank you. Claire, you had a question?
Got two or three, if I may. Thank you. Thank you very much for coming in, and it's an interesting presentation. I have read the paper that was presented a couple of years ago now. I think it probably is. And it just brings home to a question that I had raised last night, and it's been raised quite a few times by my local community on the northern side of the Waimakariri, particularly around the Air River. Now, I'm not sure how familiar you are with that, but I imagine from your diagram that it's very much a connected river and sits in the groundwater aquifer. So resurgence, when that river comes up and it runs, and then it goes dry for long periods as well. So, but the community's really concerned about the floods. They're not so concerned about the groundwater aquifer and the recharge, which we know is valuable as well. So, I mean, there's an awful tension there. And so how do we cater for that? And that river has got some stop banks on, particularly in the lower part, when it is diverted into the Waimakariri, of course. Quite an engineered one during development. But this I think is something that you probably would see right across New Zealand for those sorts of rivers. What do you say to that community, or what can I say to that community?
In my mind, I'm going to speak my mind here, is the issue is one of how you value the river. And the river, the Air obviously it's valued for its flood protection. The money that gets put towards maintaining the Air River is going to come primarily from flood protection, for flood protection purposes. If you increase the value base of that river, so if it also has value for providing groundwater recharge, you could potentially put more money into doing things with that river. But that involves working across disciplines. So that involves the flood engineers working with perhaps the groundwater people to maintain that flood protection capacity, but at the same time increase your groundwater recharge. Now that may not be the case with the air because it goes dry, it's an ephemeral river. But for rivers that are perennial, like the Waimakariri, that's certainly the case. I hope that answers your question. But it's essentially, I think it's about how the river is valued and how the funds are attached to those values. What I see is that funding tends to be partitioned. So the flood engineers will get a certain amount to do so much work, and the groundwater people will get a certain amount of work. The river hydrologists will get a certain amount, but there's not a lot of latitude to, cross over. And I think that's the key.
Yeah, I think just adding to that, certainly the community wants gravel taken out of it. They see the gravel coming up relative to the bridges, et cetera, so they are concerned about that. But, you've just made me think about, well, maybe I can offer some thinking back to them. So that's good around that one. I guess the other one for me came from Hawke's Bay. I lived in and brought up in the headwaters of the Waipawa River, and going back into the 1950s, very clean, braided river. So, 4 or 5 k's down from the little weeny tributaries that start that river. Probably for the last 30 odd years, it's actually just become weed infested and things now. So the slope, there's something that's changed there that we haven't actually had that bed cleaned out. Is it just solely climate change effects, or is there something else actually going on? Because you've talked about, and I can understand it lower down where we get more weeds, where we've actually channelized things, but nothing happening in some of these headwaters.
I have to confess I don't know that river, so I can't really comment on it, but it sounds like there's been an erosion issue that is just ongoing, hasn't been resolved. So you're getting just a legacy effect of that. Yeah.
I guess that's the question, isn't it? Is that we're a very young country, so our plains are still forming, and so therefore some of these rivers here, they cut down naturally, and then, land can be farmed. You had an example of some irrigators there, and I'm pretty familiar with that Marae-Kākahu area, so know what goes there too. But very interesting, thank you.
Craig?
Kia ora. Thanks so much, Scott. And thanks, Vicky, for organising it. I just had it, my mind's not quite worked out the bed raising, bed lowering thing, because so keen to, if you could elaborate a bit, because I would have thought that bed raising is like a problem, and because rivers are constrained a little bit, is the aggration or whatever, that's what happens, and that creates more of a flood risk. But I think you said in the slides that bed raising is a good thing. So can you just explain that a little bit?
Yeah, it's a matter of perspective. So if you're considering flood protection, raising the bed could be a bad thing, depending on the flood capacity of your design system. From a perspective of ecology or groundwater surface water exchange, raising the bed is a positive thing because it brings the water table higher. It's a little bit like...
Go back to that slide that was showing the perched.
Oh, yeah. Yeah.
And then just go through about bed raising, the difference between...
Like that one?
Yeah.
Yeah.
Because you were talking about it there.
Yeah, so... Like you can see, I don't know if you can make out in that top right-hand diagram, there's a water table on either side of the river system. You can imagine that if you dropped the riverbed, the water table would also drop. And likewise, if you raised the riverbed, the water table would also go up. It's a little bit like, you imagine if sea level goes up, the water table around the coast would go up. And conversely, if the sea level was to drop, the water table would drop. So it's just the way the groundwater system is adjusting to the things that control it. So the main controls on groundwater are, are rivers, the sea is controlling the discharge end of things, and there's a certain amount of geological control as well. Does that clarify it?
Scott, can I just say, is what you're saying that a bed raising? Not used to being at this table. That's right. That a bed raising, it would really make sense from the wider values under the connected, but actually makes less of a difference under the perched. That's what I heard you say? Yeah.
Yep, exactly. Whereas the widening makes a big difference in the perched or the narrowing, and makes less of a difference if it's connected. So if you widen the rivers in the upper parts of the plain, you'll get more groundwater recharge. If you narrow them, you get less. And as you move towards the coast and the river system enters the water table, the widening or the narrowing makes less difference to the groundwater recharge, whereas the bed level makes more difference. So dropping the bed level in that sort of Coots Island area of the Waimakariri, that's obviously having a big impact on groundwater recharge around for the Christchurch system. We can't really get much of a handle on the effect of bed narrowing because most of that was done in the 1960s, and we didn't really have much in the way of groundwater monitoring back then. So it's hard to actually gauge the exact effect of bed narrowing that occurred when the schemes were put in, the flood schemes were put in. So we kind of have to model that and make predictions that way.
Thank you. Peter.
Oh, thank you. This has been really helpful actually to understand some of. What was it?
All right.
To understand the way these rivers work, and it seems to me, as an observation, having sort of been trying to pay attention and sitting in this room and looking for different ways to manage rivers, and there's a phrase that's often used: we need to give the rivers room to breathe. But to me, there seems to be unintended consequences of any engineering possibility that you want to put in to change rivers. From what I'm hearing from you. And the reason for that is pretty substantial development on those margins around rivers, and also like Te Waihora. I mean, we went out there and had a look at that, and where the old bank is way up here. And if we let the rivers do what the rivers do, then that would flood a substantial area in that catchment. So, I mean, my question is, what do you think is possible?
I think it is possible to give the rivers a little bit more room. Now, I'm not a flooding engineer, so that's where I need to work with flooding engineers to understand the impact that widening that fairway would have on flood capacity. I know that it would increase groundwater recharge, but then there's another question that we don't understand, and that is, what would that do to flow in the river?
So can I just stop you there? I think you made a very good point, because, I mean, you said at the start of that you're not a river, you're not a flood engineer, and so it seems like if we're going to do anything along these lines, it's multidisciplinary approaches to what we're going to do, because if you increase groundwater, you also increase the opportunity at the coast for flooding, and going back to the way things were, like the Hinds become a swamp again, like it used to be. Yes, Mr. McKenzie, your swamp that you drained. So, I mean, I think this has been really interesting from your perspective, and saying these are the things that will change if you do something, but understanding what the consequences are, to me, is a risk. Do you think that's right?
Yeah, definitely. And that, like you say, that does involve working across disciplines. That's the key, and that sort of tends to be uncomfortable for us. I'm not a braided river geomorphologist, for example, but to do this work, I've had to work with braided river geomorphologists, and I remember we spent the first 2 years of the program just trying to understand what each other were talking about. We had to feel silly. We had to be okay feeling silly. Yeah. So that's the bottom line.
Thank you. So I've got Yayan. You are on my list, Nook, but there were a few before you put your hand up. So Dion.
Thank you so much for your presentation. I found that quite interesting. And Peter has actually already covered a number of the points that I wanted to talk about, especially around the interdisciplinary nature of where we go to from here. Because you've touched on some of the economic, the economic. Right on your last slide, you were talking about the economic positives around widening the rivers and everything like that. But something that I think is I'm acutely aware of is we're in the situation of the world that we're in at the moment. We've got banking systems, we've got insurance systems, we've got investments on all these plains and around rivers. And what I really wanted to understand is, has there been any of that economic or that financial work that you've done looked at the other sides of the markets around insurabilities and risk? And if you did the scenario of widening the river or raising the bed, has there been any consequences from, say, talking to insurers about the insurability of downstream of those rivers and potential costs that come into people who live in those areas or do activities in those areas? It's a very, very complex and a very ugly place at the moment for regional councils to be in, given some of the situations that are happening around the rest of the country. So, yeah, really appreciate the work that's done here, but there's a big picture that I think needs to be thought about. And I was just wondering, has there been any thought of that in this work, or is it just kind of looking at a narrow scope?
So the economics that we did were on the Wairau and the Ngātaroru, and they were specific to those reaches of river. Every situation is going to be different, obviously. There were two things that we did. We made sure that we didn't change the flood capacity of the system. So thinking about insurance, it kind of took that out of the equation a bit. So the insurance situation wouldn't change from the way we were reconfiguring the river. So we did scenarios where we widened the river and we changed the bed levels, and then we did economics around those. So in each case, the flood capacity was assumed to be the same. So if we raised the riverbed, we would raise the stop banks, and we'd cost that in. The other thing that we didn't account for was some of the local iwi values. And the reason we didn't account for those is that when we consulted with the iwi that had mana whenua over those rivers, they considered that it was either should be done properly or just not done. And they suggested that to do it properly would be really, really difficult, so we didn't do it, and that was their recommendation. So those are some of the assumptions behind the economics there. Yeah.
Thank you. Yayan.
Kia ora, Scott. Yeah, that was going to be my question. You looked through the whole thing here. I mean, Nook wanted to, as soon as he came in, he got all grumpy because he looked at the history and said early settlers faced two problems, flooding and sedimentation. But it was like, what you're talking about, which first settlers? Because Māori used to work with the river and the environments, a long time before anyone else turned up. But why? I mean, because my thing is, where's mana whenua in this, in this model? And you just said, the iwi values weren't included. So how could? Yeah, I know you said they said they wanted to be a full scale model. So what would that look like? Just so I just need to understand why they just weren't in, nothing's in there.
That was their recommendation. Yeah. That would be, they considered that would be quite a lot of work. That would be a really big piece of work in itself. So it was their recommendation was just to do it without iwi values. And there was a certain perspective that the iwi and the environmental values were aligned. So from that perspective, there's obviously a lot of values that aren't considered there. Like Muri, Whakapapa, They're not considered in that valuation, and they need to be to do it properly. Yeah. In terms of the settlers, what I mean there was the early settlers. Yeah, they kind of created the problem. Yeah. 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 Yeah.
Mackenzie over here and me. But yeah, so it'd be good to put up the create the problem. But,
Yeah.
so just so you said alternative approach. Oh, sorry, Chief, I've got a few questions. Alternative approach here on the last slide. Yeah, amateur Tim, hey. Mackenzie back out. So any examples of that where this has actually started to work?
Yeah, we are working on the Wairau River. In fact, we had a workshop here at ECAN yesterday because we were drawing on some of the experience from the ECAN river engineers. It's a difficult one, and the starting place there has been to get a really good understanding of gravel extraction. That's really the starting point, because when you understand how much gravel is being extracted, how much is coming into the system naturally, you get a much better appreciation for why the bed is going up or down, and also some of the changes in bed form. One of the problems that we came up against is that there's things that I think that we need to do to that river system, which the engineers tell me that we can't do. But it actually just comes down to money. Like if you had the money, you could do it. So it was interesting. We looked at one section of river where it would cost about $5 million to try and raise the bed for a bunch of rock, putting rock in the bed to recover it. But it seemed more appealing to put in a canal and try and put water in on the other side of the stop banks. I know that one approach is going to be more effective than the other. I'm not sure about the costs. Perhaps they'll be similar. But the question is, how do you pay for that? How do you pay for the restoration? That's the bottom line, really.
Thank you for that. And Councillor Mackenzie or Claire kind of alluded to a little bit of it. And then with that picture up there, the connected and perched, it would have been good to have this probably a couple of months ago before our gravel management strategy, because there's some things in here that kind of pertain to that. But so if you raised gravel extraction, not good for recharge, right? So if you extract all the gravel, drops down, then you end up in perched. Is that correct? Whereas over extract, so if you stay connected and left it high, it helps with the recharge. Yeah. So I mean, that would have been good a couple of months ago. Anyway, thanks for that. Kia ora, Scott.
Yeah, just to say, Scott has been in connection with our staff, so hopefully the right staff who've been involved in gravel. I don't know, Tim might know. We've certainly had, you guys have had Scott come in and talk to you, so this is new for us, but not for them. Nook.
Kia ora, Scott. Morena. Interesting, I've just been at the court actually. They're talking about the quality of the Lake Hawea water quality. A lot of it had to do with all the tributaries coming into the lake as part of it. Hey, look, I just have a couple of questions, but I just want to make a comment. Is that my colleague over there stole a bit of thunder. Well, not so much thunder, just probably a light rain that's coming. But I just wanted to know, because early settlers faced two problems, and the rest of that headline should be that they originally caused. Because if you look at flooding and sedimentation, it was actually about taking the korowai of Tāne Mahuta off the whenua, which causes that. So that's that there leads to another thing, is that when you did this work, I mean, were you talking to all of iwi across Aotearoa?
No, we just engaged with local iwi, and it was difficult to do because a lot of iwi do their engagement. It's like they're not necessarily getting paid for it, so it's voluntary, and so it's actually quite hard to get the engagement because you're asking a lot from people's time. And I think one thing I learned is that when we do our future research, we really actually need to put aside a fair whack of money to pay people to be engaged, so that
Supplementary. So, because I just go back to a March 23 briefing we had on river revival, and Mana Whenua were actually involved in that quite, had a considerable involvement in it. And they were talking about the degradation of the awa. And this was actually, in this takiwā of Environment Canterbury. So some of the comments were that the gravel extraction to them was always going to be detrimental to the awa, to the river. That was the first thing. The second thing is the degradation causes, and they actually targeted the Rakitata, was about the combination of 1920 extraction of gravel and water. And then the second one was intensive chemical farming. And the third one was draining over 2,000 hectares of wetlands. So all of that, and then they came to productive economies, and particularly talking about, how we create wealth is our issue. It's about how we manage its creation and balance with the environment. And that's obviously, we do get royalties, we can do, around gravel extraction. And it was kind of tied into that in some ways. So a lot of it too was around the whole river approach, that they were talking about. And I see it's kind of in, in this. And you're right, it's good that we know that you're talking to our staff here, because I'm like my colleague here, is that it would have been really good to have this kind of information around the with the gravel extraction, all of that, hui's that we had. So getting to the question.
Please.
So do you reckon that, do you see yourself and this work as being the ambulance at the bottom of the cliff?
That's a leading question.
I kind of see it as the start of something, of doing things different. Yeah. I think we can be smarter about how we do things. And it does involve exactly what you're saying about seeing the river as a whole system. I liked what you said about taking gravel and taking water, because essentially when you take gravel out of the river system, you are taking water. And you're taking a lot of other things too. Yeah.
Yep, thank you. Look, this is great work, because I'm not quite sure about our relations all around here, saying that in some ways I am, if you're not going to do it, so what is right? You said that, they said, what does done properly look like? And if you're not going to do that, well, then don't do it at all. But I what I'm getting out of this is that you're looking for a way to do it as properly as you can. Okay. And then I think that's the way it should be pitched back to Mana Whenua, because we've got to start somewhere, because we can't just let it sort of, just keep going on the way it is. So thanks very much for the presentation. Sorry I was late coming in, but kia kaha.
Just, I'd like to follow up that. The next piece of research that I'm looking at doing is really on understanding how all of this has impacted the actual flow and also the ecology. Because when you modify the river in some way, it changes that balance. So I'm really interested in particularly in engaging with iwi on that, because I think that's really valuable. Yeah.
Thank you. And Grant, if we've gone quite a time over, but if just ask a question, that'd be, and that's the last one. I don't think I've got anyone else waiting. So.
Just quickly picking up on the values, broadening the values and how we appreciate our waterways. Yesterday, we council endorsed the Braided River Revival, talked about, or one of the slides, or you've talked about the problems of pinch points in the system, and the idea of allowing rivers to breathe. So the economic part of that whole thing is should we be looking at the secondary overland flow paths that nature had created for us? And are those pathways a way of dealing with the flooding issues, continue to put in harm's way close to our forced riverbanks? Is that the effects of allowing that? Is basically, do you think it's, if you use a secondary overland flow path, it's a quick, sharp way of removing a quantity of water, and then after that's gone, you can do things, and the main stem and stuff that we've created still exists?
That's a really good question, and it's something that's been talked about in the aftermath of Cyclone Gabriel on Hawke's Bay. Do we actually start to look at reactivating some areas that traditionally would have been flooded? Of course, it's going to have a massive impact on some of those landowners. There's also the question of whether there's been land encroachment over what really ought to be considered riverbed. That's a big issue too in Canterbury, I understand. But it's a good question, and I think that needs to be something that is, would be considered on a case-by-case basis for sure. Yeah.
It's wonderful. Thank you. Thanks, councillors, for your questions. It was really great to see how engaged and interested you were, and the questions you had, I think, brought a lot more information to us. Your presentation was fabulous. Thanks, Scott. I knew it would be. And thank you for staff as well to actually have introduced me to Scott's work. So, no, it's really wonderful. Thank you. Kia ora.
Thank you.